This is section 2.4 on complex numbers. So with a complex number, we have some real number matched with an imaginary number. So the imaginary number we call I. So I is defined as the square root of -1. Since we know that we can't have negatives under a square root, if that does happen, we end up getting an imaginary number. So therefore, if I is the square root of -1, if we square I, we get just -1 because the square of a square root cancels and we're left with -1. Um, so basically, what this is all saying in mathematical terms is the square root of any negative number becomes I times the square root of that number. So here I have some examples down here. The square root of -6 is I square root -6. The square root of -9 would be 3i because we can actually find what the square root of 9 is. It's a nice whole number. So we write it as 3i. So we prefer when it doesn't simplify out to put the I in front, whereas if it does simplify and we're not left with a square root, we put the I on the right side of the number. So now a complex number is a real number plus an imaginary number. So A plus BI is what we use to represent a complex number. A is the real part, so the real part of our complex number, and B or BI is the imaginary part, so BI on the end. So here, 3, 2, 3i, and 2 plus 3i are all complex numbers. So 2 is missing the imaginary number, 3i is missing the real part, and then 2 plus 3i has both the real and the imaginary part, but all three of those are considered complex numbers. So 2 is our real number, 3i is pure imaginary, it's just an imaginary number, and then 2 plus 3i is an imaginary number. Because anytime you have I in your setup, it is considered an imaginary number. So we can graph these points in the complex plane. The complex plane looks just like our xy axis, except instead of this axis being x, it's called our real axis. And then instead of this being our y, it is the imaginary axis. So when we have any complex number in the form a plus bi, we can plot the point a comma b, so whatever this number is as your x, and then the number in front of I as your y, and that will give you the point you use to represent this complex number. So here, 3 minus 4i, 3 on the x, and then -4 on what we know as the y, but it's 3 on the real axis, and then -4 on the imaginary axis gives us this point that represents this complex number. When we are adding, subtracting, and multiplying complex numbers, our first step is we want to simplify all of the radicals. So like down here in part C, we would want to simplify these radicals out as much as we possibly could. Then step 2, we want to think of I as x. So we want to add, subtract, and multiply as usual. So in these, it's kind of like combining like terms. We're going to combine the real numbers and we're going to combine the imaginary numbers. We can't combine real with imaginary. They have to stay separate. And then finally, we want to simplify it down to the standard form, which is real plus the imaginary. So if we do that in this example right here, um, we have -3 minus 4i plus 5 minus 2i. So we want to combine our real parts, -3 plus 5 would give us a positive 2. And then we combine our imaginary. -4i minus 2i, we get -6i. And I write it in standard form, real minus imaginary. Moving on to part B, so if there's a minus sign, make sure you distribute. So we want to distribute the minus as our first step. So 2 plus I plus 4 minus 9i. And now we combine like terms. 2 plus 4 is 6. That's our real number. And then we have positive I minus 9i. We get -8i. Once again, real part comes first and then the imaginary. For part C, we first want to simplify these radicals. So we can write both of these as I square root 9 times I square root 4. So now when we multiply I times I, we get I squared. When we multiply, or when we simplify square root of 9 and the square root of 4, we get 3 times 2. So we would get I squared times 6. Now, before on the first slide, we said that since I is equal to the square root of -1, I squared is equal to -1. So this would be the same thing as -1 times 6, which is -6. And that's important to know that I squared needs to simplify to -1. We will never have an I squared in our final answer. We only ever have a single I. For this part, multiplication, we want to FOIL. So first, outside, and so forth. So we get 2 plus 4i plus 3i plus 6i squared. So notice 3i times 2i. When we multiply 3 times 2, we get 6. I times I is I squared. Just like we did here, I squared becomes -1. We want to do that here as well. So we get 2 plus, we can combine these like terms, 7i plus 6 times -1. Now to simplify further, 6 times -1 is -6. And now we can combine 2 minus 6. We get -4 plus 7i. And real part comes first, imaginary comes second.